Hello everyone. In this video we will see how we can use the load and store instructions to do memory operations, like how we can fetch the value from memory and how we can put it back, and of course we'll see in that regard we will see different instructions here. So let's previously we have done arithmetic operations and like how we can connect to the Pi. I hope you have got that concept there. So today I'll write the program to write some instructions for memory, and we'll see how they work. So let's write a program. Let's say we have load and store .s. all right. So now since we are talking about memory, so definitely we will need some memory variables that we can declare, and of course we will access them and we will change the values as well. So let's see, now we have a program which should be divided into two different sections. So first section will be .data section. So in this section you will declare your variables, but before declaring your variables there is another directive that you should put here, which is for the alignment. So since our memory is 32-bit address space, so and just to make sure that each variable will be separated by the 4 bytes, we should assign it here that the alignment should be 4, which means 4 bytes. So the variable that I'm going to declare, that should be word size, means it's 4 byte size. Alright, so let's say we have a variable, let's say we have variable a, okay, and it is followed by the colon, and then we should add the directive word, and this is the value 3. So this means I have name of the variable a, which is the word size, means which is 4 bytes in size, and the value is 3. Alright, similarly we can have another variable, let's say b colon dot word, and we can put the value 4 or maybe 5. Right, so this is the variables we have. Now for example, we need to access them and we want to do some operations on these variables. Now we'll write some code. So for that purpose we will add the directive .text, means now that our code section is getting started. Alright, so this is the data section and this one is the code section. So in code section, again just to be on a safe side, we will put the alignment 4, because the instructions are all 32 bits in size and the alignment should be 4. So just to make sure, we added this line, although we don't need it, but just to be on the safe side. Alright, and then we add our main program here. So let me put it on another line. So dot global main, and here is the main going to be defined. So let's say we want to load the value of variable a. So before doing that, we also need to declare the addresses as well. So just after the main section, what we need to do, we need to give the labels for the addresses of these variables. Alright, so let's do that before we write any load and store instructions. So I write the label address underscore a colon dot word a. So this means this particular label is going to hold the address of the variable a, which is declared here. Right, and then we need another address label for the variable b. So I will write it as address underscore b followed by colon dot word b. So this will hold the address of b. Now coming towards the code section again, and we need to load the values of a and b one by one. So first we need to load the address of these variables before we can access them, because we should know the address so that we can like directly approach there and access the value. So first we need the address. So we will write the instruction LDR. So this is the new instruction you are seeing here, so which is the load instructions. So first load instruction is needed to load the address of the variable A, so that will be LDR R1. so this can be any general purpose register here that we can put here. So LDR R1 comma address underscore A. So this line holds the, or this register holds the address of A, and now we need to access the value in this address, so we'll write another load instruction which is LDR R1 comma square brackets and R1. So this means that dereference the address which is in R1 register and move the value which is declared in the memory into the R1 register again, although you can give another register as well here, but just we can do that within this one register as well. So and if you want to give this to any other register like R2, you can do that, but we can do that within this register as well. So let's keep it R1. So before there was the address of the variable, now it is dereferenced and the value 3 should be moved here in R1. Alright, and similarly we can load the another variable address and another register, let's say LDR R2 comma address underscore B, and we have another instruction to dereference it. So LDR R2 comma square brackets R2. So this is dereference. Now I have two variables values stored or loaded in the registers R1 and R2. Alright, so this one holds 3 and this one holds 5. Now for example, I want to add the values of these registers and want to store them in another register, third register. So let's say I have add instructions here. I say add R3 comma R1 comma R2. so this will add the values and we'll put the result here. Now as we know that the result is now residing in R3, and what we want to do is that we want to store this value back into the memory. Alright, so let's say we have another memory here, we can name it as variable C colon dot word and initialize it with 0. Alright, again we will need the address of this register here as well, for this variable C as well. So we have address C followed by colon dot word C, because again as we first time we needed the address of these variables to load the values, we again need the address of that memory variable where we want to move this result. So after adding, we can say so first we need the load instruction again to store the answer. Alright, so what we can do is that we say LDR R0 comma address underscore C, and we want to move this value here in this address, so we'll say str. So str is the instructions to store the answer. So str R3 into R0 dereference. So since this was the register which was holding the address of C, like where we want to put our result, so we need to dereference it. So once this is dereferenced, and this value will be moved into this section. Alright, so this is how you store the values. So Now for example, we want to see see these results, and of course we will again go through this program with the GDB debugger. We will debug it and we'll see the all the answers here. Alright, and in case you want to see the result on the console, so like for the addition of these variables, so you can also write this move instruction here. So let's say you want to see this answer, so you always need to move this answer into R0 register. So since this is not now needed, so we can say move R0 comma R3. Alright, so once this is done, so the value can be displayed on the console as well, just to see the answer. And before that, these instructions we can go through with the GDB as well. Alright, so let's save it, and I want to compile it, so I will change the I will change this make file. Alright, so I can replace this with the load underscore store. Alright, so let's change it one by one. And this is from where the .o file binary will be created. Alright, and from this binary file we wanted to create the link executable file. Alright, so we need here load underscore store s file, which is our code file. So this will be sampled here, and this is the link file. Alright, will be created from the GCC command, and this will be the o.o file will be created from the assembler command. So in case we want to clean the files once they are created, so we can write here load underscore store and all the binaries if there are any in the folder. Alright, so let's save it. Just a second, we need one more change here. So this is load underscore store, so this is the thing that should be created. Okay, so now we can save it. So what do we have currently here? We just have the load underscore dot s. So let's now make command. So we can first run make clean. Alright, so this previously .o file is now deleted. So what do we have here? These files. Now we can run make. Alright, so it is now done. So let's see, we have the now load underscore store dot slash this executable file. So if you want to just see the result here, let's say dot slash load underscore store followed by semicolon echo dollar question mark. So here's the answer is 48, which is the wrong answer. So let's visit back, sorry, not the file but the code file. So we have load instruction here and here. Okay, so we can run the GDB dot slash load store. Maybe this problem is identified from the GDB as well. That's why we use debugging. So GDB dot slash load store. Let's do that. Alright, now we say start Okay, start it. So now disassemble it. So currently my program counter is pointing here. So first instruction will hold the will load the address of the R1, which is of course placed at this particular location. Alright, so once we move it one step I. Alright, so now it's on the other instruction. Now if you want to see the content of the R1, so you can say info registers R1. So R1 holds this is the address of the variable A. Alright, so in case you want to make sure that this is actually the address of the variable A, so there's an instruction that you can write to check that. So that instruction is b ampersand, and you can simply write the variable name. Alright, so you can see that this is the address which showed here in the R1. That means the instruction is loaded correctly. Now when we run the next instruction, which is this one, this should now hold the value, whatever the value was here. So if you want to check the variable value here declared in the memory, you can write p space ia. So in this case, saying the unknown type. Let's say we write this. So that's how you can get the value of this variable A, which was declared in the memory. Alright, so let's run that instruction, step I. Alright, and now check the value of info register R1. So R1 now holds 3. So previously it was holding the address, now it is now dereferenced and loaded the correct value 3. Alright, so what's the next instruction do we have here now? So this is to load the variable b. Alright, so let's load that. So step I. Alright, and we want to check the value of register 2. So this holds the address of the variable b. So again, if you can see, so there's a difference of 4 bytes. So that means the alignment is correct and the variables are separated by the 4 bytes in size. Alright, so now we can check the address here if this is the correct one. So we can say p ampersand b. Alright, so this is the address, so that means the address is correct. Right, and now you want to check the values. What is the value placed at this address? You'll say p, the brackets and we can say b. So that means 5. So we can also use these identifiers with p command to see the values at this particular stages at the identifiers. So for example, you can write $4. It will say it was 5. Now it's new identifier. In case you want to see the identifier of 3, so that showed the address. Alright, and similarly we had this identifier 2 holds the 3. Alright, so there you go. So now we have now this instruction which will load the value on this address. Right, so we just run that. Okay, and now we will say info registers R2. Alright, it should hold 5. So, and it is holding now 5, which means now it has correctly dereferenced the value from the memory and moved it into the register R2. Alright, and the next instruction is about add. Alright, so before doing that, we just see the values of R1 and R2. Alright, and in case you want to see value of R3 as well, so which is some chunk value. Alright, so after the execution of this instruction, R3 should hold 8. Alright, so let's do that. Step I, and this step I is resulted in these values. So we can see now, once the add instruction is executed, the answer is 8. Alright, so after adding the result, we wanted to store this answer back into the variable C. Alright, so for that purpose we need the R0 register here, where we have loaded the address. So just load that. So just before that, if you want to see where we are actually standing at, so this instruction is going to execute. Alright, so step I. Alright, and we want to see the value of R0 as well. Right, so this one holds the address of the variable C. So in case you want to see, to double check it, you can say p ampersand C. So you see we have the correct address in the register R0, and now we want to move this answer into this address location. So we'll assemble it again, see. So this is where it's pointing now. Now run this instruction. See the results. So since this value is moved to this location, we need to check the new value. Alright, so it is the correct value which is moved there. Alright, now let's run the last instruction. Okay, so what mistake we did, that we did enter the exiting statement, which was the bx space lr instruction. Alright, so although like till this instructions we can see that the answer is correctly moved into the variable C. Alright, but just to make it clean finish up, we will quit this and add that line that we mistakenly missed. So I'll say yes. So when word space to s, so the ending instruction was missing, due to which the problem occurred initially, that we got wrong answer in the first place. So we will say bx lr. So that was the returning statement that we missed. Alright, so we will say make clean. Okay, we'll make again. Alright, now if we run $/load store and colon echo $, so now the correct answer is placed, because the returning statement was true, because the control should be given back to the operating system.
So that was the problem we did in this instruction. So that was a very basic mistake. So again, if we want to run the GDB, alright, so I will say start. Alright, and this assemble again. Alright, and I want to add, for example, I want to add the breakpoint at the very last instruction, just so this instruction won't be executed, the terminating instruction here. Okay, so I'll say break at this address. Okay, so which is the 0x001003F0. So let's try that again. So let's check it again. So this is the correct way of adding the breakpoint. Alright, so it is adjust now. So again, if you want to see the disassemble, so alright, so what was the command to execute it till the breakpoint instruction? That was continue. So write continue. Alright, so it is now stopped here if you want to see it. Alright, so this is the exiting instruction that hasn't executed yet. And before that, if you want to see all the results that you have done so far, so what we did, that we loaded the values of variables a, b, and we added them and stored the answer back into the value in the variable c by dereferencing the registers. Alright, so if you want to see the results in the registers in the first place, so you can write R0, R1, R2 and R3. So these are all the answers that are here till now. And in case if you want to see the value in variable c that is correctly placed, so again you can write this command p and space c. Alright, so 8 is there. So that's how it's all done. So that's how you can use the load and store instructions specifically for accessing the memory and modifying it. That's how you can do that. Alright, now I will run the last instruction because this is the instruction that will go to the other routine that will get back the control to the operating system. So I'll simply write continue to end this program here. Alright, so this is exited now. I can put the debugger here. Wait. Alright, so that's how we have done this memory access and modification. In the next video we will see how we can use these instructions with the arrays, how we can declare the arrays, and how we can access them at the different places, and we can do some other operations as well. Alright, so that's all for this video. Thanks for watching, and please subscribe the channel. Thanks.